For a given metal, the simplest possible value proposition is to take all the properties of that metal that you like and increase the strength by a factor of, say, 5, right? So if you really like aluminum because it is lightweight and tough and corrosion resistant, those are all good reasons to like aluminum, but it's frequently not strong enough to be used as a structural metal to replace, for example, steel. So aluminum now 5 times stronger, now you can think about pushing it into other markets where you might have used some other metal in the past, compromising on a secondary property like weight or density. If you care about other metals, for example, if you're interested in wear and corrosion, you might have used a chrome-based coating in the past and put up with the environmental baggage associated with producing that chromium coating. Now we have a new option on our hands, which is to take a different metal like nickel, control its internal structure and produce the same set of properties, and deliver it without the environmental baggage associated with the alternate metal that was in the marketplace before. So I think the bottom line is take any metal, make it about 5 times stronger, and think about where you would use it that you couldn't before. So I would say that the metallurgical industry in general has a lot of niches built into it. So one metal will be used for one application, another metal for another application. There are a lot of relatively narrow niches, and we don't often think about viewing this as a portfolio where one metal can substitute in for another. And that is to a large extent because the metals have different properties. You cannot simply swap them for one another without making compromises in the property sets. So this does affect supply chains. It does affect supply and demand, and it affects the environment. There are very important implications globally about the use of metals based on the properties for which we use them. So one of the big reasons I'm interested in manipulating the internal structure of metals is that I firmly believe that metals, they have an incredible palette of properties. One particular metal can be as soft as butter with one internal structure and harder than anything on the market today with a different internal structure. It's all about coordinating the way those atoms are structured and built. So we should look at metals as more of a portfolio proposition. If we don't like the way one particular niche is treating us in the market, we should think about looking for ways to make different metals substitute in. How can we manipulate the structure of aluminum to replace steel? How can we look at the structure of nickel to replace chrome? Those kinds of questions are absolutely addressable with today's science and technology and metallurgy.